Welcome back to our Algebra 1 series. Today we're up to section 4.3 where we will be covering trinomial squares. As we've seen in the past, when you square a binomial, you end up with one of two different trinomials. The sign of the middle term of the trinomial matches the sign between the two terms of the binomial, as seen here. The square of a binomial is a trinomial. Such trinomials are called trinomial squares. So how do we recognize a polynomial as being a trinomial square? There are three different rules that we need to follow. First, two of the terms must be squares. And we're calling these a squared and b squared. Two terms must be something that is squared. Secondly, there must be no minus sign before those same two terms. And finally, the third term must equal 2 times a times b or the negative 2 times a times b. Let's move these down here and take a look at an example. X squared plus 6x plus 9. Looking at the first rule, two of the terms must be squares. We're calling those a squared and b squared. Well, x squared is x squared and 9 is 3 squared. So we met the first requirement there. That's good. Secondly, no minus sign before the a squared and b squared terms. Yep, there's a plus sign in front of both of those there. And finally, the third term must equal 2 times a times b or minus 2 times a times b. And if we work this out, 2 times x times 3 is 6x, and minus 2 times x times 3 is minus 6x. So yep, we've got a match. This is a trinomial square. We've met all the requirements. Let's jump over to the whiteboard and try to identify some trinomial squares. Okay, we've got our trinomial square rules up here. Let's write down a trinomial and see if it is a trinomial square. We're going to do 16a squared minus 56ab plus 49b squared. That's a b. Alright, so first rule, do we have two things that are squares? Well, this here is 4a squared, right? And this one over here is 7b squared. Okay, so we have two things that are squared that gets us up to here. So we've met the first requirement. Secondly, there's no minus sign before a and b. Okay, no minus sign and a positive sign. Okay. So finally, if we take 2 times a times b or minus 2 times a times b, we get this term in the middle. So let's just take 2 times, remember this is a in our formula and this is b. 2 times a times b. This is 56ab. So yep, we got a minus sign of this. So this could be plus or minus. It just happens to be minus in this case. So this one is a trinomial squared. Let's try one more here, but we got to clean this off first. Alright, let's do something like this. X squared minus 12x minus 4. Okay, so looking at our first rule, do we have a square and a square? Yep, this is x squared, and this is 2 squared. Second rule, no minus sign before the square. Uh-oh, we got a minus sign here. This is not a trinomial square. But for the sake of the example, what we're going to do is change this to a plus. Alright, so now we've met the second requirement. What's the third requirement? 2 times a times b. Remember, this is a, this is b. So 2 times x times 2 is 4x. So again, we have another mismatch. So even if this were positive, we do not have a trinomial square because 2 times x times b to ab in this case is minus 12x versus 4x. There's no mismatch here, so this is not a trinomial square. Next, we're going to look at factoring a trinomial square back into the squared binomial that we started with. So in this case, we know we have two possible options, a positive form or the negative form. This one has a plus 6x, so we know this will fit the positive form. Looking at the squared terms of the trinomial, x squared and 9, we know that x is the a portion and 3 is the b portion of the template. And 2 times a times b is 6x. Remember, the a and b are just placeholders for the binomial that we're trying to get back to. In this case, it's x plus 3 quantity squared. If you were to multiply x plus 3 quantity squared using FOIL or the template at the bottom, you would end up with x squared plus 6x plus 9. Let's take a look at this example. It's a little sneaky. First, we need to find the common factors. For this particular problem, we can pull a 4 out of all three terms of the trinomial that we're starting with, and we're left with x squared minus 2x plus 1, all multiplied by 4 that we had pulled out. So looking at the trinomial that we have left, the x squared minus 2x plus 1, is this a trinomial squared? And if so, how do we factor it? So we've got our rules down here that we've gone through a couple of times. If you look at all three of them, we can see that yes, this is a trinomial square. And in this particular case, it matches the negative form of the binomial square to trinomial formula. The placeholders here, a and b, are x and 1, because x squared is x squared, and 1 squared is 1. So this ends up being 4 times x minus 1 quantity squared. All right, let's go right back to the whiteboard and factor some trinomials. All right, let's put down a trinomial here. X squared minus 14x plus 49. Now we're not going to worry about identifying this as being a trinomial square. We're just going to factor it. These problems we know are going to be trinomial squares. Let's just factor this. So if we look at what our a is here, let's just write over here. A is equal to x, and b is equal to 7, right? Because a would be x squared, b would be 7, which is 49. So let's take a look at this here. We've got a minus sign here. So we need to figure out what times what would get us a minus 14x. So we know it's going to be something squared. It's going to be a binomial. We know the first part is x, and we know the second part is 7. So because this form is the negative form, we've got a negative term here in the middle. That means that this boop, 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 becomes minus. So again, if we were to FOIL this out, we'd end up with an x squared. We'd have a minus 7x, another minus 7x, which gets us the minus 14x, and 7 times 7, which is 49. Let's do something a little more complicated looking, but I'm sure we can handle it. 25x squared minus 70x plus 49. Yeah, okay. So I'm going to write down again A and B. So A, what is one term squared? So 25x squared. What do we square to get to 25x squared? Should be 5x, and this is 49. Oh, that would be, oh, we just did that, 7. Okay, so I should have written up here 2ab as well. 2ab is 14x. Remember, we need plus or minus. So yeah, just good check there. So let's just write down 2ab again here. What's 2 times a times b? That would be 70x. Remember, we're looking for a plus or a minus, which we have. So it all matches up. We're in the minus form here. So we're going to create another binomial. I'm still on the screen, just barely. All right, so what's the first half of the binomial? It's 5x. And the second half of the binomial is 7. Because we're in the negative form, we end up with a negative here. Again, if we were to FOIL this out, we'd go back to this trinomial. And that's it for the new material. If you'd like to see more examples, stick around. Alright, we're going to go back to trying to identify a trinomial as a trinomial square or not. plus 16x minus 64. That's a very sloppy plus sign. Something like that. Okay, now looking at our rules, we know automatically that this is not a trinomial square. This minus sign right here, you can't square anything to get minus 64, right? So this is not a trinomial square, so we can rule this out. However, let's just pretend, right? Is this a trinomial square? Well, we've got something squared here. This is x squared. We're going to call this a squared, right? And this is 8 squared. We're calling this b in the template formula thing. And is this 2 times a times b? 2 times a times b. That's, yeah, 2. Oh, yeah, so 2 times a times b to 8x. That's 16. Okay, so this is a trinomial square. All right, let's do something a little more complicated. 8x squared plus 40x plus 25. Okay, is this a trinomial square? Well, before we do that, is there anything that we can factor out of all of these? 2 and a 4. And there's no common factors. All right, so let's just look at what we have left. Do we have 2 things that are squared? Well, this is 5 squared, right? What do we square to get this? Nothing nice with our numbers. So this is not a trinomial square because of this 8x squared out here in the front. Okay, let's do one more identification problem here. 9x squared, that's a 9, I promise, minus 14x plus 16. And this was not a trinomial square. You get out of here. All right, do we have 2 things that are squared? Yep, we've got 9x squared, which is 3x squared. So this is the a in our template. You've got 16, which is 4 squared, which is b in our template. We've got a positive sign on both, so that's good. And is this middle term 2 times a times b plus or minus, right? So 2 times a times b, 2 times 3 times 4, that's 6, that's 4, 6, that is not. So this is not a trinomial square. So you get out of here too. All right, let's clean this off and factor some trinomial squares. Alrighty, here we've got x squared minus 14x plus 49. So we're going to end up with something squared. The first term will be something that's squared up here. And the second term will be something that's squared up here. And we need to make sure that those 2 things, when multiplied together, times 2, gets us this middle term. And this sign is kind of a little preview. We're going to have a negative right here. So x squared is x. What squared is 49 is 7. I'll just do a double check here. If we were to FOIL this out, we'd have an x times negative 7 and negative 7 times x, so we'd have negative 14. So yep, this is how we'd factor out this equation. We know we have 2 terms that are squared. Those are these two terms. 2 times this term times that term equals this term, and the sign matches. Let's do 2x squared minus 40x plus 200. Okay, so we know things are going to be a little sneaky around here because we've got a common factor that we can pull out of all this to make it a little simpler. So what's a common factor between all 3 of these terms? Now we can pull a 2 out of each of these because it's x squared minus 20x plus 100. Okay, so that makes sense. If you were to, distribute this 2, you'd end up right back where we started. So now we've got a trinomial here. And is this a trinomial squared? Well, it sure looks like it. So what we're going to do is, do I have room down here? We'll do it over here. This equals to 2 times some binomial squared. And this little minus sign is a little clue. We're going to have a minus here, right? So we need something squared. That's the x, because this is kind of the a in the template, a squared. And now we have this over here, which would be 10, which is b squared. So 2 times a times b, 20x, and the negative matches the negative, and there we go. All right, let's clean this off and do our challenge problem for the day. Okay, here. Oh my gosh, 81 x to the 6th plus 72 x cubed y plus 16y squared. So just because there's bigger numbers and more variables and exponents, the same rules and same lessons can apply. I'm going to tell you right off the bat that this is a trinomial square. So we're going to go right to the form of something being squared. Now we got a positive sign here. That's a nice little clue. We're going to have a plus here. So what squared gives us this first term? What do you have to square to get 81 x to the 6th? Well, you know there's a 9 in there because 9 squared is 81. This is x cubed. Remember, x cubed squared is x to the 6th. And over here, 16y squared. What squared gets us that is this. Now let's just think about this for a second. Does this make sense? If we were to FOIL this out, we'd end up with 9x squared. Yep, that one matches this. And this is our squared term. So 9 times 4 is 36 times 2 times x squared y. So 2ab. I'm going to write this out just so we have it. This is the 2ab part of the template. So it's 2 times a, that's a cubed, times b, 4y. 2 times 9 is 36 times 4. 2 times 9 6. Yep, so if we multiply all these together, we get 72x cubed y. So that's the term in the middle. So yep, we kind of double check this, we get back to where we started. And that's it for today. We'll see you next time.